Hey everybody, for this video you want to make sure that you understand the concepts that I covered in the central angles and arcs video. This one we're going to be covering arc length, sector area, and you should be able to find an arc length and a sector area in a circle by the end of this video. Arc length is the distance along part of the circumference of a circle. So arc length is related to circumference. And so it will have the circumference included in the formula for arc length. So we will use the measure of an arc, which is related to its central angle, theta, in this diagram. So the arc length is calculated as the measure of the angle ABC, so that's the central angle, divided by 360 degrees, which is the entire circle, multiplied by 2 pi r. And so this right here, that is the circumference. So the other part of the equation, the measure of angle ABC divided by 360, that tells you how much of the circumference we're talking about, how much of the circle. All right, so let's look at this example. So we have here, measure of the angle is 40 degrees over 360 degrees times 2 times pi times the radius, which is 2 in this case. For an exact answer here, we have 0.4 repeating times pi feet. And if we give that as an estimate, we have approximately 1.396 feet. So what we're saying is this distance right here from point A to point C along the circle has length 1.396 feet. All right, now for sector area. So here what we're talking about is we're talking about the area of this slice of pie. And so because it's part of the area of the circle is going to need to be included in the formula. So the definition here is the portion of a circle enclosed by two radii and an arc. So the formula here will have to include the area of the entire circle, but we also need to include the portion of the circle that we're talking about. So the measure of the arc, measure of arc AB, divided by 360 degrees, that tells us the portion of the circle we're talking about, times pi r squared. And right here, this is the area of the circle. So we have the area of the circle multiplied by the portion of the circle that we're talking about. All right, so let's look at this example right here. So the portion of the circle we're talking about is 40 degrees divided by 360 degrees. We're going to multiply that by the area of the entire circle, pi times the radius squared. So when we give the exact answer for that, we get zero point 0.9 repeating times pi centimeters squared. And interesting thing about zero point 0.9 repeating is that it's actually 1. So here we have pi centimeters squared. And if we want to give an estimate, it's approximately 3.14 centimeters squared. If you're interested in that idea that zero point 0.9 repeating is the same as 1, look it up. It's pretty wild and surprising thing in math. All right, so have a look at these examples, and I'm not going to go through each of these, but what I suggest is that you pause the video, give them each a try, and then put the answers up here. You could start the video up and you have a look, and I'll give a quick explanation of each. So on the first example there, measure of arc AC. So what we're looking for is this arc measured in degrees, which is the same as the central angle, so it is 85 degrees. The second one, measure of arc ADC, we know it must be a major arc because we're using 3 letters to name it. That means the measure of it has to be greater than 180 degrees. So what we do there is we do 360 degrees, subtract 85 gives us 275 degrees. On the third one, length of arc AC, now we're going to talk about this in meters. And so the formula that we use there is the portion of the circle that we're talking about, the central angle divided by 360 degrees, multiplied by the circumference, 2 times pi times the radius, which is 5. The exact answer here will be in terms of pi, and the estimate will not. On the last one, the area of sector ABC, so we're talking about the area of this slice of the circle, and the portion of the circle that we're talking about is 85 degrees, the central angle, or the arc measure, either one, divided by 360 degrees. And then we have to multiply that by the area, pi times radius squared, and the radius is 5. The exact answer must include the pi, and the estimate will multiply the 5.9027 repeating times about 3.14. It turns out to be something like that. All right, you guys, I hope that this makes sense. And welcome back to uh, learning with me here today. And I hope that this distance learning and goes well for you. It's new for all of us. So I'm glad to be back working with you all.